So one thing to note about this proof, so as I mentioned, we have u must be in the k wave because the distance of u is smaller than the distance of v. So really, we need an if and only if for this to work. So we update our claim to be a little stronger. So in particular, v is in the k wave if and only if the distance of v is equal to k. So with this updated hypothesis, we're now inducting on this distance of v technically. Now this will be the same as k, but to make the proof work out right, we will technically compute on that. So when the distance of v is 0, well, we know the only thing of distance 0 is the set s, and so it's in the 0 wave. That's all correct as before. But now for this part, we argued that the distance of u was less than the distance of v, and so we can imply the induction hypothesis to conclude that u was in the k prime minus 1 wave. Now why does this help us? Then everything else follows as before. Because we know it's in the k prime minus 1 wave, then we know the algorithm would have added v earlier. And so we would have gotten the correct distance. But it's important that this is an if and only if, because we need to use the other direction. We already know the distance of u and need to know it's in the k wave to figure out what the algorithm's doing. Whereas before, without the other direction, we've only been able to conclude if it was in the k wave, then that's true, but that's not helping us. So just an example where sometimes you need to strengthen your induction hypothesis or your lemma in order to get everything to work out. And that sometimes things that are obvious, like using this k wave, sometimes it is too good to be true, and you really should use the more standard thing like distance.